2, 1. Welcome. This is, I guess, a video on the test for Introduction to Quadratics. If you want to be able to download it, I recommend that you do. Give it a shot after you've watched all the Quadratics videos. So the playlist to the Quadratics, I'll put it up above. Now in those playlists, basically you will have everything you need in order to solve this test. So if you want to download the test itself, the PDF version, it's going to be in the show notes. Okay, so you'll find that there for yourself. And once you do that, you can take, I guess, probably about 60 minutes or so to try to see if you can knock these off. And then you can return and check for yourself if you got the questions correct. So I'm going to try to do a walkthrough every single question here. Let's get started. So question 1, use the distributive property to expand fully, then state if the expression is a quadratic and why or why not. I'm going to take this whole thing. So let's bring it down and then I'm going to expand it out for us. So is this a quadratic or not? And now I can actually already see it's not a quadratic. The reason for that is because it has two variables, x and the z, and actually it has a y there as well. And because of that, it cannot be a quadratic. So quadratics, recall, are always going to be in the form when you expand them out, ax squared plus bx plus c, where the a, the b, and the c are some numbers that we have. I mean, technically, typically they'll be integers, but they don't have to be. The a is not going to be equal to 0, because if it was equal to 0, then you would just have bx plus c, and it would not be a quadratic anymore. That would be just an expression, basically a linear expression. So I know that it's not going to be a quadratic. Now, let's use the distributive property to finish this question. And in order to do that, you have 3 terms. So here is one term, here is your second term in the bracket, and here is your, and I apologize, you have 3 factors. So 3 factors in here. So here's the first factor, second factor, and then the third factor. I'm going to expand all of this out. So let's take this, expand it across here first, so we can do that. And that's going to give us negative, it's going to be 6xz, and then negative 10x. That's going to be the expansion through the first one. Now, once you have this, you can now expand it through 2y plus 5. And again, so you can use the distributive property, so that's going to go through here. Now, this one's going to be a little bit more annoying because we're going to have to do all of them. Let's do that. First one, so I will have negative 12. I'm going to keep the variables in alphabetical order. So I'll put negative 12, I guess, x, y, z. It's the first. The second one is going to be negative. Now this is going to be 30, x, z. The next one is, so the negative, so it's going to be negative 20, x, y. And then finally, you're going to have negative 50. It's going to be that, x. And as you can see now, it clearly is not a quadratic at all, although I could tell right from the beginning, just simply because of the number of variables that you would have. You would need only one variable if you really wanted to have a quadratic expression there. All right, so that's question 1. Now let's go up. Question number 2, use factoring to simplify the expression. So we basically are going to factor out this entire thing. So let's do that. Going to, so let's take this junk. Actually, let's keep it. I'm going to paste. This is number 2. And then we're going to try to factor this whole thing out. First thing is on the coefficients. So the 18, 9, and 6. I will take out right away. I can see that I can factor out a 3 out of all of them. So that's going to be 1. So I'm going to take out a 3. That's going to, what is that going to remain? Okay, so now each single term here, so this term, and this term, notice they all have an A. what is the maximum that I can take out from there? Well, I have a squared, a, and a cubed, so I guess I can only take out an a. That's that. Now for the b, I can take out a b from all of them as well, and then I can take out a c. So that's going to leave me, so in the first one, so that's 6, because 3 times 6 is 18, and then I guess I will have just a single a remaining. That's there. Now the second one, so that's going to be, if I took out the 3, it's going to leave me a 3. The a is going to be gone. There's only going to be one b, and then the c is gone as well. And then the last one is going to be -2 remaining. And you're going to have a squared remaining, no b, and then you're going to have a c. And this is as far as we could factor this whole thing out. The factor in the bracket, the entire thing that you see there, I can't really do any more factoring with that because I have an a, b, and then I have an a squared and a c. So I will leave it in that particular form. All right, so here is kind of my biggest one, my biggest factor that I could take out from all the terms. So that would have been question number 2. So it's the opposite of distributing. Now we have factored. All right, question number 3. Let's take a look here and see what they have. Factor the following expressions. All right, so now I can see that we're starting to get into some actual quadratics. Now in these, so let's paste it. I'm going to keep coming back to these and I will do them one by one. Now they are all quadratics. I don't know if I can actually factor them out, but we will see. All right, so the first one, which is going to be the y squared minus 7y minus 60. So in this particular example, because my a is actually equal to 1, so what I'm going to look at is I'm going to have, so 1, so I have 60, right? So I have to break down 60 in this one, and it is -60. So one number is going to be positive, one number is going to be negative in terms of the numbers that I'll choose. Now in order to get 60, and I'm just looking because I need -7 when I add them up. Oh, so that's going to be, I guess, 12. So -12 plus 5. -12 plus 5 is going to give me -7, which is going to be the -7 there. And then indeed 12 times 5 is 60. And therefore, so that factor, so for part A, what I have, it's going to look like y, and it's going to be -12 times y plus 5. And that would have been the factor form of that particular quadratic. So it looks like it has kind of 2 factors that I can do this one for. All right, and of course you can check for yourself, if you're doing a test, you can quickly check. So again, these 2 numbers, okay, when they multiply, have to give you -60, which they do. And then when you add the numbers, -12 and the 5, they're supposed to give you -7 back in order to get that A that you see right there. So that's that. So that one was not bad. The second one, so for B, and now notice I have -10x squared minus 24x minus 8. Right away, because the a is negative, I don't want the a negative, so I'm going to factor out the negative out. So I'm going to do that first. And then I also notice in this example that I have 10, 24, and 8. So those are my coefficients, my a, b, and c. And I can actually factor out, what can I take out? 2. Yeah, because 10 is 2 times 5 in terms of primes. That's actually as good as it comes. So for part B, so I'm going to first take out -2 out. All right, so I'm going to factor that out. So that's going to leave me 5x squared plus, I took out the 2, so that's 12x, and plus, that's going to be 4. So notice that's factored out the -2. And now I'm going to take this quadratic, and I'm going to see if I can break this one down. So 5 times 4, well, that's 20. So So that's going to be 20. And now, what are the two numbers multiplied together that are going to give me 20? And then which ones would that be, right? So then I have 12x in terms of adding them up together. Well, 20, so 5 times 4 is 20, but of course that's not going to be the one. 2 times 10. So notice 2 times 10 gives me 12, right? Because 2, so it's going to be 2, 10, which gives you multiplied together, gives you 20, and added together gives you 12. That's what we have. And now I can factor this whole thing out. So let me, do it by decomposition. So negative 5x, so plus 10x plus 2x. So I've decomposed that 12x into 10x plus 2x plus 4. And now I'm going to factor. So I'll take out the 5x from here. It's going to leave me x plus 2. And therefore, so that means x plus 2 is going to be my factor. And then what does that leave me? And just take out a 2, I guess. And there you have it. So factoring this whole thing out, so I'm going to have 5x plus 2 and x plus 2. And then I can't forget, so here is my negative 2. And that would have been the factored form for this one. So that's pretty good. All right, so that is the factored form of this particular quadratic. Now C, all right, C is nice. So right away when I see this, now this is actually not a quadratic. It's a to the 4, right? So the exponent is 4, so it's not a quadratic. However, I can see that there's a difference of squares there. And for example, the 16 is just 4 times 4. Right, a squared is, a to the 4th is just a squared to the square. And then 121, well, if you take the square root of that, it's going to be actually 11, right? So that difference of squares, so this one there isn't really much to do here. So for difference of squares, you have to kind of remember that this is going to be, so the signs have to be opposite. And this one's going to be positive. And then that is your factored form for that. That is it for C, actually, right? So there isn't much more to do. So the difference of squares are pretty neat to be able to quickly tell what they are. And then the last one, and let's do that. So I'm going to just take this one out. I can't see exactly what this will be factored. But I do see there's a 4 in front, and actually 4 can be factored out from the 24 and the 36, so that should help. So I'm going to do that first, and let's see what I have left. Y squared plus, that's going to be 6y plus 9. All right, well then this one is much simpler. This looks actually like a perfect square, and because it's 9, that's correct, it is a perfect square. And because 9, if you take the square root of 9, notice that it is 3. And 3 plus 3 is 6, right? So this thing is a perfect square. So it's going to be x plus 3 squared, and then don't forget the 4. And that's the factored form for that. Perfect. All right, so that's another question knocked off. And I wonder if you got this one on your own. Let's go back here. That was question number 3. Question number 4. Okay, so for all quadratic expressions in question 3, now quadratic expressions, so this was quadratic, and this was a quadratic. That B was not, that C, question C, was not a quadratic, and this one was a quadratic. So for all of those, identify which, if graphed, would open up and which would open down as a parabola. All right, so these are expressions, but parabolas, so in terms of relationships or relations, well, so recall. So, this is parabola opening up, and then this is a parabola opening down. And the difference was that for this, A had to be greater than 0. And then for this, A had to be less than 0, right? So that's how these ones looked. So this is not very hard to be able to tell. So we see that this one and this one, these ones are parabolas opening up, and then this one, B, because it's -10 for A, so this one would be opening down. So those are it. So that's part A. Part B, find all the zeros or the roots of the expression. And so this one is pretty neat. Now I'm going to go back. Luckily, I don't think I erased it, but when it's already in factored form, then it's much easier to find the zeros. So let's go back here in terms of the roots. So let's go back to those questions. So what did we have? So for part A, all right, so we have this one. Let me clean it up a little bit. I'm going to steal it away. So that's for the first part. Copy it, and let's find the zeros of this. And in order to find the zeros, what you do is you always just take each factor. So you take a factor, and then you set that factor equal to 0, and then isolate. So that means y minus 12. Okay, you're finding the 0 of that expression, which means what does y have to be in order for this expression to turn into 0? Well, if you solve this, so this is just moving this on the other side, so this is going to be y is equal to 12. So notice, if you would plug in y is equal to 12 into here, right, and it's going to be into both. Now it doesn't really matter what it is. So what you would find is you would get 12 minus 12, and then you would get 12 plus 5. So that equals to 0 multiplied by 17, which is 0. So that's called a 0. So you found the 0. You found what value of y is going to make the expression a 0. And those ones are sometimes called roots of an equation. Now in this case it's an expression, so I guess it's just zeros. So that's one of them. And then the other one would be the other factor. So you would take now this factor and you would solve this. So you would have y plus 5 is equal to 0. Well, that's simple enough. And that means if you would plug in y is equal to -5 into that equation again, or into that expression, sorry, you would find that it would give you your 0. So your zeros for part A are 12 and -5. That it has 2 zeros. And a quadratic will always have 2 of them, right? And sometimes they're different and sometimes they're the same. It just depends on the quadratic. So in this case, we have 2 zeros, 12 and -5. That's for part A. For part B, let's go in here. So again, I'm going to take this because it's already nicely in factored form. If it's not in factored form, then you would have to factor it out to be able to find those zeros for yourself in here, but we've already done that in the previous example, in the previous question. So in here, so what you do, I mean, there is clearly a factor which is just a number in front. Now, you ignore that. And, you know, because -2 is just, it's constant. It won't change for us. So what we do is, if you want to find the zeros, you just take each factor. So in this case, I would take this one. That would be my first one. And I would say, okay, so for this factor, and if I set this to 0 and I isolate for x, so it's going to be -2, so 5x, and then divide both sides by 5. It's going to give me this. And what that means is, again, if I substitute this into this expression, this factor is actually going to be 0. Notice that what it will give you is, so for that factor, so it would have given you 5, you substitute -2 over 5 plus 2, and so the 5s would cancel and you would get -2 plus 2, which is just 0, which would make the expression 0. So that's one of the zeros. The other 0 is going to be related to the other factor, which is this one, and that one is much easier to tell. And because if you're going to be solving that for 0, then you're just going to shift that. So that means my zeros are -2 over 5 and -2. Those are my actual zeros of that. So perfect. So I have found, that's for B. For C, for that question, well, we don't have a quadratic, so we're not going to work with that one. That one is to the power of 4. So that's what we would have there. But for D, so when we solve D, which is, I guess here it is, so that's the last one right here. So copy. So this one is a perfect square, which means it's going to have the same zeros in this case. So there's two factors, so don't forget this is basically 4, x plus 3 and then x plus 3. That's why we have the squared right there. And really these ones are the same, right? So you take x plus 3, you set it to 0, and then if you shift it over on the other side, that is your 0. But it would be the same for that. So we have two zeros here which are exactly on the same spot, which is -3 and -3. That's what we have. All right. So those are my zeros. Now let's take a look what else they want in that particular question. So that was part B. Graph using a digital tool. So for example, Desmos. All right. Okay, so let's use Desmos to plot these out. So we have, so let's plot these things out. So it's y squared minus 7y minus 60. So let's take a look at that. So I'm going to put here Desmos. Now it's y squared. So I'm going to just change the y to an x to make it just a relation for graphing. All right, so let's do that. So y squared. And there we go. I forgot already. -7, -60. Okay, let's go back here. So -7, -60. So this is how it looks like. There we go. So notice it's opening up like it opens upwards. That's what we have there. All right, so that was the first one. If I go back there, actually for part D of that question, it says, what do the zeros from part B mean on the graph? And if you recall, if you were watching and studying this, the zeros actually, what they mean are, they are the x-intercepts of that parabola. And if you go back in here, so I'm going to go back right here, and let's say if we plot it, so notice -5, 0 and 12, 0. Those are exactly your zeros. So the zeros on the graph, on the actual graph, they represent the x-intercepts. So here it is, so 12 and -5. Notice that was for the first one. And now for the second one that we have, if we graph that one, so it's -10, -24, and -8. -10, -24, and -8. -10, -24, and -8. And notice that, let me get rid of the first one there. Okay, so notice this one opens downwards, and that makes sense because the A is negative. And notice these zeros, so where do they happen? At -2 and then -0.4. And that's what they were actually. If you go back, it was -2/5, right? If I recall correctly. So here it is, -2/5, which is -0.4, and then -2. So it was just your x-intercepts that you have. And then the last one here, it's going to be, so here it is, so it's in, here's the factored form of it. You can plot the original one, which was 4, I guess, y squared plus 24y plus 36. So 424, 36. 424, 36. 24, 36. There we have it. And look at that. And so in this one, the 0, so notice that in this case what it represents, so the -3 right, that we found, the 0 of that, that's exactly where it cuts through. So basically touches the x-axis. This is really just your vertex in this case. So that's what it represents here. Now the roots, there's 2 zeros in here at -3, but they just so happen. And when you do have a perfect square, that's what may turn out to be. Now it will just kind of shift over depending on the values of the B's and the C's that you have there. All right, so that was the graphing. I hope that you got a chance to try that. So that's a pretty neat question there. Question number 5, find the line of symmetry and the vertex of the following relations. Ooh, okay. So this one, I guess not as nice. Let's take a look at these. So find the line of symmetry and the vertex of the relations. Let me first do the first 2. Then we'll go back there. Okay, so we're not going to do it through graphing just because we want to be able to know how to do this. All right, so we have to, so that's the first 2. If I concentrate on the first one, so notice 3x squared plus 7x plus 5. Of course, it would be great if we could factor this out. Now I'm looking at this, we actually can't factor this out because of the fact that 3, 7, and 5 are all prime numbers. So therefore 3 times 5 is 15. Now in order to get 15, I won't be able to get that 7, or at least it will not be in a very nice form for me. It won't be just regular integer numbers. But it's not asking me to factor this, it's asking me to find the line of symmetry and then the vertex. So right away you will recall from the videos that I've done. Now, if you've forgotten about the line of symmetry, all right, so I'll put up a link, okay, up above there. You can take a look if you want. So in order to do that, I basically zero things off. So what I do is, so first, what I'm going to try to do, so the step is, I'm going to set my y is equal to 5. That's what I'm going to do first. So that's going to give me, so let me write this out. So I'm going to get 5 is equal to 3x squared plus 7x plus 5. Now moving this 5 over on the other side, so that will be gone. It's going to be 5 minus 5, which means that I have this. Now this is very easy to factor because, okay, I have, so I'm going to take out the x, and then I'm going to have 3x plus 7. And there you go. So for y is equal to 5, what I'm doing is I am finding, so if you think about, you know, the parabola in here, so as the parabola goes, basically for the value, so what I'm trying to do is, and let me do that. So what I'm trying to do is I'm trying to find, all right, and this is for the value of y is equal to 5. It's going to give me 2 points within here. And one of those points, okay, so this point is going to happen at x is equal to 0. That's my 0. So one point is 0, 5, all right? So that's this point, 0, 5. And then the other point, so comes from here, which I'm going to set that to 0. And that's going to give me 3x plus 7 is equal to 0. So I'm going to shift the 7 over, so it's going to be negative 7. And then notice that dividing by 3, I'll get x is equal to negative 7 over 3. So that's this point right there. So that point is, so this point right here is basically negative 7 over 3, 5. So now I have found my 2 points, and the line of symmetry, so the line of symmetry that breaks this thing down basically goes through the vertex, right, and it goes kind of cuts it in the middle. So what I want is, I want to know what this value of x in the middle is. And in order to do that is, I'm going to add the 2 points and divide by 2, right? Now adding the 2 points, that's just 0 for x, okay, right here, and then negative 7 over 3. All right, so I guess these things are swapped. So x equals to 0 is actually here because this is negative. So that's that. And so I'm going to have negative 7 over 3, now divided by 2. So if I'm dividing this by 2, it's going to give me negative 7 over 6. That is my line of symmetry happens right there. That's my line of symmetry. All right. Now, it's also asking me for the vertex. So the vertex, I know what the x value is, but I want to know what this value is, right? I want to know what that vertex is. So in order to do that, I will have to take my original equation and now substitute into that equation the negative 7 over 6 to find the value of y. Now, so what is that y value? So it is, y is equal to, so it's 3. It's not going to be very pretty. 7 over 6 squared, right? Plus 7, negative 7 over 6, and plus 5. Plus 5. So what is that going to be? All right, so let me just pop out a calculator because we have these fractions. I'll save a little bit of time in here. So we have the following. So it's 3 times. Now we have a fraction. Actually, so that, let's put that in brackets because it's going to be squared. So fraction. So negative 7 over 6. Oops. We have that. Let's close that in. That is squared. And now, so this one, the next one is actually much easier. So notice it's 7. So this is going to be 7 times negative 7 over 6. So that's going to be actually, so 7 times 7 is 49. Now it's going to be negative. So this one I can actually go ahead and do right away. So 49 is going to be over 6. So that's when you do that. And then that's going to be plus 5. Plus 5. Let's see what that gives us. I'm going to leave it as a... So it wasn't that bad, actually. So it's 11 over 12. And that's my vertex. So my vertex happens at negative 7 sixths and 11 over 12. All right, so that's what we have. So 0.9166666. And then, 7 divided by 6. This one is 1.1666 if you're putting it as a decimal. That's your vertex, and that's how you would go about doing that. If you wanted to kind of recall and go over those vertex, I'll put up a link to that video for you there that talks about finding the vertex, okay, if you've forgotten it. All right, so that is the first one. And let me go back to this test question. And for that test question, it says find the line of symmetry. Okay, so we found that. Now in question 6, it says graph the relation, then graph the line of symmetry, and graph the vertex. So that's neat. Okay, so let's do it for that first one that we just did. So let's graph this whole thing so that you can see, it in action, I guess. So it was 375. Let's do that. So y is equal to 3x and 5. So notice it actually had no zeros, right? It doesn't go through the x-axis. So this is what we have. So we have that. Now the line of symmetry was x is equal to negative 7 over 6. And look at that. It's a beautiful line of symmetry that we found. So we have seen that. And then it asked us, I guess, negative 7 over 6. And it was 11 over 12, right? That's what this was. And let's label that in. Beautiful. All right. So this is what we have. So this is the entire thing graphed. Our line of symmetry for the parabola. So it's symmetric around that axis. And then we have found our vertex. All right, perfect. Okay, let's take a look. So there's, I guess, a couple other examples. Here is one. So we have this one right there. So I'm going to copy that. Let's work through this one. This one is a perfect square. So if it's a perfect square, then this one will be a little bit easier for us, because in a perfect square, we already know, all right? So what we're going to have is, so from this perfect square, when it's a perfect square like this, then we can find our 0 right away. So we can set y is equal to 0. And so that y is equal to 0, which means you're going to get 4x plus 12 equals to 0. So let's solve for x. That's going to shift the 12 over. 4x divide by 4, it's going to give us this. All right, so that's what we're going to have. I'm just scrolling up. All right, so that's what we have. And we have 2 of those zeros. So that means that not only, so what this is, when it's a perfect square, that point, so it's going to, the point is -3, 0, right? And then there's 2 of them that are happening because it's a perfect square, so there's 2 of those zeros, but they're identical. So what you found is, in this case, notice that if you would expand this, the a would have been positive. So your parabola, basically what you found is you found the vertex. So when you have these perfect squares, it's great because you can find the vertex right away. And of course, the line of symmetry just goes through that. So your line of symmetry is this. That is your line of symmetry that you found. And your vertex is -3, 0. Okay, so let's graph that. And that's going to be the second example. So 4x plus 12. Let's clear this. Y is equal to 4x plus 12 squared. All right, beautiful. So this is what we have. Notice you can see that. X is equal to -3. It's your line of symmetry. And then your vertex happens at, let's label that in. And there we have it. So that's what happens. Quadratics are kind of nice because once you find the 0, it turns out that you can just plot out and get the actual vertex right away, and then the line of symmetry as well. You don't have to do as much work as we did for the first example, where we were finding 2 points, finding the middle, and then finding the line that goes through that middle. All right, so that's the second one. I think there was one last one on this test that we have, and I think that will be it. Actually, hold on. Those are, yes, there is one more. Okay, so we have this one. So I'm going to copy this. And let's grind away through this. So paste. So that's another quadratic. Now notice the A is negative, so this parabola is going to look downwards. It's going to be something like this, or our vertex is going to be somewhere there, and our line of symmetry is going to go like that. Now I'm not going to play around with this one. I will just, use the strategy of setting my y equal to just my c. And so that's going to give me -7, so -x squared plus 10x minus 7. So those 7s will be gone. And I will have -x squared plus 10x. So I can solve for my, let me take out a -x out. And that's going to leave me x and minus 10. All right. So my zeros here, of course, happen at x equals to 0. And then from here, it happens at x is equal to 10. And that was for y. So what we have is, we basically found this. We found a point. All right, so we found 2 points. We found 2 points on the parabola. One of those points, let me now draw this one correctly. So one of those points happened at 0, -7. And then this point right here happened at 10, -7. So that's what you found. You found those 2 points. Now, to find the line of symmetry again, you add them up and you divide by 2. Well, one of them is always 0 in this strategy, so it's going to be 10 divided by 2, and that is going to give you 5. So here's your line of symmetry. So your line of symmetry happens at x equals 5, so it's the vertical line. Now, once you have this, so you know that it happens right there. Now, what you want is you want to find the vertex. So you know the x value, which is 5. Now, so what you're doing is you're taking the parabola and you're intersecting it with the vertical line, right? And you want to see where they intersect. Well, they're intersecting at x equals to 5. So you're going to plug that into your equation. So if you plug it into your equation, you get y is equal to 2. So let's plug in 5. This is 5 squared, 10, 5 minus 7. So this one's a little bit easier to work through. Plus 50 minus 7. And that's going to be, so that's 25. 25 minus 7 is 18. So it looks like my vertex happens right there. All right. Let's plot it and then see how, what kind of a job we did here. So it was negative 1, so 10 minus 7. So negative 10 minus 7. Y is equal to negative 10 minus 7. Guess that's that. Blow this up. Okay, so it looks like that. Now the line of symmetry happened at 5. Indeed, that's what it looks like. And then my point, what was it? 5 and was it 18? All right, and let's label it. Okay, there we have it. So here's your parabola, here's your vertex, here's your line of symmetry. And that is it. All right, so that completes this test. I wonder how well you did. You can put your results in the comments, and I wonder if you actually remembered all of these. Okay, so that's the introduction to quadratics for grade 10. Okay, thanks for watching. We'll see you in a future video. Bye, everybody. Cheers.